Hi, everyone. Welcome back to the Princeton AI Alignment and Safety Seminar, or PASS for short. PASS is a virtual and collaborative space for diverse researchers to learn and discuss how to align increasingly capable AI models for safe behavior. I'm Sadika, and I'll be hosting today's session with Yongsabo and Professor Sanjeev Arora. This seminar will be 1 hour long and live streamed on YouTube. During the session, you are welcome to post your questions or comments on the YouTube chat. Please also consider joining our mailing list and following us on Twitter to get notified of our upcoming speakers and the live stream links. You can find the links in the chat. Today, we are excited to have Irene Suleiman, Jennifer Mickle, and Usman Gohar from Hugging Face joining us. Irene is an AI safety and policy expert. She's the head of global policy at Hugging Face. Usman is a PhD student and an F. Wendell Miller Scholar in the Department of Computer Science at Iowa State University. Jennifer studied computer science and mathematics as a Turing Scholar and Polymathic Scholar at the University of Texas at Austin, where she was a Dean's Honored Graduate. Today, they will be talking about evaluating the social impact of generative AI systems in systems and society, and we're really looking forward to their talk.
Thanks so much, Sadika. Well, hello, everybody. Part of this incredible project that we have been chugging on for a couple years now is to be a resource. So please, as we said, please interrupt. Please share with us how this resource can be most helpful to you. And just for some background, my co-lead Zirak Talat and I conceptualized this project a couple years ago based off of how little guidance we found in the AI space on how to evaluate aspects of safety, such as privacy, such as fairness. When I was back at OpenAI working with Statica, I was thinking about how do we look at these GPT-3 level systems along some social aspects of safety axes. And we just decided to build it. And it's been absolutely an honor and pleasure to work with Usman and Jennifer and many of our other, you'll see a list of some of the incredible faces across many different expertises to have this interdisciplinary work. And we'll also share with you some of the limitations of how difficult it is to evaluate incredibly qualitative aspects of systems. I'm gonna hand it off to Usman and Jennifer, who are gonna be your guides for this presentation.
Alrighty, thank you, Irene, for that wonderful introduction. Yeah, my name is Usman, and me, Jennifer, will talk about our work evaluating the social impact of generative AI systems and society. Like Irene said, this is a huge collaborative effort with more than a couple of dozen researchers, policymakers, working in industry, academia, and all over. So let's just get into it. So yeah, as we all know, AI and then generative AI is kind of, everywhere and being adopted really rapidly for different applications from, people using it, like companies using, like Apple using it for generative AI power editing for Photos app, or people using it for, cover letters for jobs, so on and so forth. And all of these companies are kind of integrating AI systems, and especially generative AI systems with their existing products or creating new products, kind of like and so there's been like a plethora of activity, and every kind of day you'll see a new application for this. So while there's been a lot of positive aspects of it, one of the issues, like Irene said, has been the problem of the negative social impacts of these systems, right? So when machine learning AI kind of started off at the beginning, researchers found that artificial intelligence had kind of like a bias problem, where it was struggling based off someone's protected attributes and things like that. And with the advent of generative AI, that kind of, quadruple. Like if machine learning and AI were bad, I think kind of like generative AI is kind of making that even worse, considering that it is able to generate a lot of content in a really short amount of time. So there's been concerns for things like disinformation, propaganda, environmental issues, performance issues, fairness, bias, all those sort. And I think one of the biggest issues that have come up with that is the fact that with generative AI systems being trained on the large amount of data that we have on the internet. There's no specific guardrail as to what it's being trained on, so it's being basically trained to perform generically on any non-specific applications. So there's been problems such as, AI generators being trained on explicit photos of children, which was kind of talked about very recently by a Stanford study. So for all of the positive aspects of generative AI, there's a lot of social impacts issues that are under the radar or are being kind of noticed right now. So the landscape right now, the way it looks like is that there's a lot of works going on to evaluate LLMs. So the evaluations range from looking at extreme risks such as military risk or so on and so forth, and adversarial risks, and catastrophic AI risks, to something more aligned towards looking at biases, cultural value problems, and things like that. So in this space, there's been groups working on this, ML Commons, different companies, all of them having their own AI safety groups that are kind of working on developing these evals of these systems to identify potential social impact issues. But one of the issues with this is right now is that there's no official standard or guidebook to kind of have to look at where you can go and evaluate your systems for all of these social impacts. And this work kind of works towards that by providing some kind of a framework where we can delineate kind of what the issues in this space might be. So what do we mean when we say social impact? So social impact broadly is understood in the context of socio-technical systems, of how such technologies alter and fortify existing norms. So these harms and risks could be things that are pre-existing in the data set and in the systems, but also harms and risks that are being propagated and overemphasized due to the nature of the generative AI systems. So like I said, one of and I think Irene also touched upon this, is one of the motivations for this work is to kind of standardize how researchers and developers conduct impact assessments, and then how, therefore, policymakers and regulators can assess the systemic risk. And so the first step, I think, into identifying going towards a standardized framework is to identify and evaluate and kind of define a taxonomy of the evaluations. And what we mean by that is trying to identify what are the different types of social impact risks that emanate from these systems, and what the limitations are and what needs to be evaluated. So this is kind of the first step towards building that framework and standardizing that process. So in this work, what we're trying to do is kind of proposing a framework for social impact evaluations of the generative AI systems across different modalities, such as text and image, and so on and so forth. So yeah, kind of like a bit of a background on how we started off with this project. There were a couple of initial workshops where the idea of those categorization of these concepts were conceptualized. In the first workshop, essentially, there were around 30 odd researchers who came around to kind of define these categories more succinctly and kind of identify the high-level different categories of social impact. And the second workshop kind of went detailed into each of these categories to collect and collate all of the evals that have been done in these spaces, which ended up in our first version of this work, which is on archive right now, evaluating the social impact of Gen AI systems. And this was also followed up with a craft session at FACT, where we additionally discussed with the people that were present in terms of further polishing our work and also identifying evals across the different modalities, such as text and image and video. So now I think the second version of it, which will hopefully be released pretty soon, will include that additional part of different modalities and so on and so forth. So this is pictures of some of the people that are on our second We2 team. Obviously, this is probably a bit more appropriate with everyone kind of listed here. It's a big group of different people from different backgrounds, researchers, policymakers, like I said, from the industry. And I think our work is kind of emphasizing itself that this problem needs to be tackled with a diverse approach, and this is not something a certain group or certain people with certain technical background needs to come up with. Rather, it needs to be people coming from social backgrounds, technical backgrounds, policymakers, the industry, researchers, academia, right? So I think that's something that we've tried to embody in this work as well. We're trying to get as many people with different backgrounds in this work. And we've definitely seen a lot of people with different backgrounds come in and help see things that we probably did not see, or I did not see, let's say. On a high level, we kind of identified two categories based on popular deployed evaluations today, which are non-exhaustive, but these are kind of like the high-level systems that we have in our framework. So the first one is a technical-based system. And in these, we refer to AI systems, including models and components that have no predetermined application, right? So the idea of social impacts in this system is based off the idea that anyone can use these generative AI systems, not necessarily with a malicious intent, but could be used for any non-predetermined application. And these could include social impact issues such as generating stereotypes, biases, hate, some other cultural values issues, and so on and so forth. So this kind of tackles the alignment of these models generating content when someone's interacting with them. In the second, we look at people in society, which kind of refers solely to what can be evaluated in the interactions of generative AI systems with the people in society. So you could think of the second one as issues and social impact issues that may arise as people and the society kind of interact with these systems more and more. Things like trustworthiness, depending upon the outputs of these systems, trusting them, whether they're correct or wrong, and so on and so forth. So the second one kind of is more how they start to embed in our daily lives when we interact with these systems and the social impact that they can have. So understanding an AI system's social impact requires understanding not only its components from conception to training, but also the people, society, and power structures that it's taking in from the training data. So for the technical-based system, we identify 6 or 7 different categories of social impacts, things like bias, stereotypes, and representational harms, cultural values and sensitive content, privacy and data protection, environmental costs and carbon emissions, which is something that was, mostly overlooked until recently, with one of our co-authors doing a lot of incredible work in this space. Disparate performance, the labor impact, again, something that's been, really under the radar in this work previously. And then the financial costs, which include access to these systems based off of the financial impedances. So in this talk, we'll go through not all of these, but a subset of these to kind of give you a flavor of what each of these categories are and what is being evaluated in this area and what needs to be further done. So starting with disparate performance. So disparate performance refers to AI systems that perform differently for different subpopulations, leading to unequal outcomes for those groups. A model may perform unequally across subpopulations for varying reasons, such as data skew, data collection, model choice, etc. I think the seminal work, Gender Shade Study on facial recognition, I think is probably very well known across the research community, where the authors kind of evaluated facial recognition systems that classified based off of pictures of people, their genders. So these algorithms from the top big tech companies, when evaluated on their own on a high level in terms of their accuracy, you would see, if you look at the categories here, you'll see there's high performance when you look at it from an overall perspective. Like if you were to look at the accuracies of these systems, you would see that they perform close to like 99-100% overall. But when the researchers kind of deep into these, if you looked at the performance individually on intersections of multiple identities, such as female and gender and race in this case, they saw, like, for example, if you look at the performance on females, it was less or not comparable with the one that they were with males, but it was still good enough. But if you further went deeper into the in a further subgroup, in this case darker female, you could see that the performance drop is significant, where it's basically performing up until from 60s to 80s, right? And they were able to capture the largest gaps between the performance for each of these different subpopulations. So essentially, this category looks at how these systems may perform unequally across different subpopulations. So one of the questions probably we try to look at is, what do we then evaluate in these systems, and how do we ensure that we're looking at these things, right? The biggest thing is that we probably want to do is look at non-aggregated evaluations with breakdowns across subpopulations, right? So if you look at this example that we have here of, again, the same two categories, gender and race, essentially, we've tried to, this is another of the problem with this that I'll talk about in a bit. But in this case, we just look at two subgroups within these groups, like black and white, and then female and versus male. And so most of the work so far previously has just looked at independent groups, right? Look at gender independently, look at race gender independently, and then evaluate these systems. And like I kind of showed in the previous example, this misses a lot of the risks and performance issues with other stuff. So the first step to look at is to look at both the gerrymandering groups and intersectional groups, which essentially are groups that are at the intersection of multiple identities and social backgrounds. And then what we want to do is we want to imply the same criteria when we're comparing it with the highest performing group. If we look at like a language example, if we're looking at language models, they should all perform at the same level as they do in English, as it's being, the more dominant language or highest performing group, such as other languages like Arabic, Spanish, and so on and so forth. So there's been multiple works done to kind of capture and what to evaluate. There's been things like minimizing the worst case performance, which essentially doesn't bother equalizing the performance due to some other limitations that I'll get into, but it tries to improve the minimum worst case performance or look at things like subgroup accuracy as we saw in the gender shades work. So in text language or in the text modality, works like looking at cross-lingual prompting and ensuring that the performance of these text models are equal across different languages is another thing to evaluate. Examining dialects and knowledge retrieval problems with generative AI systems or language models is something else that's being looked at heavily right now. In images, most of the work has been focused on generation quality across concepts, realism, or accuracy of culture. So what these means is if you're generating images, let's say for a particular demographic, countries, and so on and so forth, you want the generation quality to be similar across the best performance or higher performing groups, right? So hopefully that kind of gives a flavor of what we need to evaluate in the systems. The limitations, one of the biggest limitations of this so far is that there's an exponential number of subgroups when you start to break these protected groups down into gender and then their race, then maybe their religion, their age, so on and so forth. So what tends to happen is like if you keep going down too deep, it becomes a tension between the individual versus the group. So ensuring equal performance or good performance across each individual is just not going to be intractable computationally. So finding a middle ground and trying to address this where you don't hit the computational limits, but you still incorporate all of these other groups is a certain direction. The other big problem, I guess, with disparate performance issues is data sparsity. So one of the reasons that these models perform poorly is because there's just not enough data on these groups. And this is not necessarily because they're not participating, but they're sometimes systematically excluded or marginalized, such as there's certain demographics that are not counted or merged under different groups like Asian Americans, and so on and so forth. And similarly, there might be marginalized due to being excluded from financial groups such as banks and lending, and so on and so forth. Another category, environmental impacts. Like I said, there's been a lot of incredibly recent work done by Dr. Sasha, one of our co-authors in this space. And what most of the works here have focused on has been issues of, the environmental impacts of generative AI systems that have kind of went under the radar. One of the examples that I probably showed up there was there was a recent work that showed how generating one image using a generative AI vision system is equivalent to charging your smartphone device from 0 to 100, right? So which kind of highlights how resource and energy hungry these systems are. So in this space, there's a lot of things to look at, things like water intake, energy consumption, what sources of energy they're currently using to run these models. And like I'll probably give this example of how the ChatGPT system was trained in Iowa, closer to a big water bodies because they need a lot of water for consumption. And there's been growing concerns about these data centers being developed in different countries and local localities where there's been issues with water consumption and intake problems. So what are kind of some of the high-level limitations in this? I think one of the biggest ones so far in this area has been the lack of transparency with how some of these models kind of use energy and so on and so forth. So when you think of energy intake, it's not just, let's say, from the training part of it. There's things like pre-training, then fine-tuning, post-training, so on and so forth, and how you maintain these systems throughout their life cycle. There's not a lot of information how much that is. On top of it, the vendors and people who've come up with these GPUs and whatnot, there's not a lot of transparency on the intricate details of these systems, which makes it harder to kind of comprehend what the metrics and values of these impacts might be. Another big one is privacy and data protection. Here, what we look at is the fact that intellectual property and privacy concerns arise with these models generating copyrighted content and highly sensitive documents or personal identifiable information. So I think there's been a couple of very popular use cases. For example, the New York Times copyright lawsuit, where they talked about how generative AI was taking verbatim the text from their articles behind a paywall. And there's been other cases where people have been able to leak training data or personal information just by not necessarily adversarial attacks, but just prompting the model in a way where it's in this case, for example, the researchers try to repeat the word poem, which kind of forced the program to cough up like whole sections of the text. So privacy and data protection is a very big concern of social impact with these systems. Second one, within the same, is that providers are not seeking active consent in collecting data, and those could have downstream harms such as security breaches, privacy violations. And these go back to my original point about these systems being trained on large amounts of data without essentially being asked for active consent on. What to evaluate in this kind of space is a couple of things. First is memorization, which basically involves looking at how much these models have memorized text of data in language models from the training data. Things to look at is sample repetitions, like how much repetition of certain samples are, because research has shown the more repetitions, the more likely the model is going to memorize that data. And then look at extractable information as to how different techniques are being used to extract that information. But all in all, this is kind of a very hard problem with regular model updates and so on and so forth. The other two problems, kind of similar: data leakage, inferring personal attributes. Both of these, even though there's guardrails on most of these systems to avoid that, we've seen certain cases where it's easy to infer personal attributes based off of some of the outputs that these systems give. Looking at audio, image, and video, one thing that we've noticed is there's less and less evaluations done in the video and image space compared to the language space. In audio and video, the most of the works what I've looked at is similarity of the generated images to training data. There's a lot of correlation with what the generated models are producing compared to the training data. There's a lot more copyright problems coming in for there. So a lot of work has kind of focused on that. And some of the audio work has focused on fraud detection models and kind of porting them for the use case of here. Finally, financial costs. I think that's just something, again, that is overlooked when it comes to generative AI systems. So the estimated financial costs of training, testing, and then deploying these systems can essentially restrict the groups of people that are able to afford to develop and interact with these systems. And what contributes to this financial cost, like I said, includes things like how do you source the training data, the computer infrastructure, the labor hours that go into it, where a lot of times they're not adequately paid for the work that they've done, and so on and so forth. Just to give you a kind of a quick example of some of the estimates that have been done, that, like, say, the Gemini generative AI model from Google, it's cost around $191 million to train and deploy, and around $80 million for GPT-4. So this is kind of an angle that's overlooked, where the high financial costs of these systems make it harder for people to make localized systems that will probably be able to handle these social impacts much better. What to evaluate in this area is probably things like data storage costs, cloud costs, and sometimes the granularity of these systems also increase the cost. For example, if you're looking at image and video systems, the number of pixels that you have in these images and videos perpetually just exponentially increase the cost of these systems, and there's something that needs to be looked at. Some of the issues that we found were some of the human labor and hidden costs are still not clear, and we're not aware really of what those are and what how much they're being these costs are feeding into the overall costs. And then the pre and post deployment costs are again something that are currently a miss in the literature. Yeah, with that, I will hand off to Jennifer, and I'll stop briefly for if there's any immediate questions so far.
Thanks, Usman. I'm going to assume we have no questions. Okay, so bias stereotypes and representational harms. So before we go into like the evaluations, let's first look at examples of this very much being a reality in systems. So this paper, Easily Accessible Text-to-Image Generation Amplifies Demographic Stereotypes at Large Scale, demonstrates that text-to-image systems amplify stereotypes. And in fact, in some cases, these text-to-image systems are not able to generate images of counter stereotypes. Specifically, what the authors did is they tried to prompt the model to generate an image of a poor white person, and what the model ended up prompting was pictures of Black folks, and then for prompting like a wealthy African man and his house, the model was unable to do that and generated a smaller house. And so this is obviously an issue because we don't want our models to be amplifying these stereotypes and being unable to even like generate counter stereotypes. And also with these stereotypes like that exist within society, like in the occupational and like traits, with the model generating a software engineer as a man and an attractive person as a lighter skinned person, these are amplifying and perpetuating social biases we have in society that we don't necessarily want perpetuated within society. Next slide. So how exactly do we measure these biases, stereotypes, and representational harms? And also, like, what should be the gold standard? So recently, like in the past 5 years, what has been really popular is developing benchmarking data sets. This was before GPT-3 became like so popular and generative AI was where it is. But with these benchmarking data sets, an issue that arose is that it wasn't clear what exactly the gold standard should be. In the example of occupational bias between gender and occupation, should the gold standard be that we match the proportion of folks according like to a particular country? And if that's the case, let's say some occupation is 20% women. Do we want 20% of the time for models to utilize female pronouns with that occupation? Or do we want it to be equitable or equal between like male and female, 50-50? But then under that scenario, what about non-binary folks? Like how often should we be generating those pronouns? So in measuring biases, stereotypes, and representational harms, it's not clear what exactly like the gold standard is or what exactly what we should expect models to do. Another issue that can arise and is portrayed in this paper listed here is that in some of these benchmarking data sets, some of the examples don't make a lot of sense. So the example right here comes from StereoSet, and the paper is called Stereotyping Norwegian Norwegian salmon and inventory of pitfalls and fairness benchmark datasets. And so what they demonstrate is that some of the examples within StereoSet and other benchmarking datasets don't necessarily make sense. So for this example, their context is I really like Norwegian salmon, and then they have stereotype and anti-stereotype sentences that correspond with that. But this example doesn't make a whole lot of sense because Norwegians haven't really experienced a lot of marginalization, so they're not a historically disadvantaged group. And also this is like discussing Norwegian salmon, and if you look at the stereotype and anti-stereotype, they're talking about exchange students, and the stereotype is that exchange students are really good at art shows and drama performances, and the anti-stereotype is that they're the star of the football team. And this example in general isn't making a whole lot of sense, and is indicative that doing this can be quite challenging. Next slide. So how exactly do we evaluate biases across modalities? So the scope of bias, like the realm of bias, has had a lot of work done. And these, except for video, there's a lot more evaluations between language and image than are listed right here. And so language has a lot of evaluations, image has less, and video doesn't have a lot, and neither does audio. And we kind of see this across the board within our paper, within the second work, that language and image have a lot more, and video and audio don't have that many evaluations. And with the language evaluations, they span a lot of different scopes of language. And what I mean by that is different like aspects of the model. So some of the evaluations that we discuss are focused on the sentence level, such as like word embedding associations, while others are focused on the sentence, where maybe they're comparing like two sentences, and then others are looking at an entire text, like text document, and looking at stereotypes or looking at something associated with that. And another problem that can arise with evaluations is that some of them require access to the model that we might not have if it's a proprietary model. Next slide. Which can pose an issue. For example, if we're looking at the likelihood that we generate a specific word and we don't have access to the logits of like a language model, we can't really evaluate that, and we can't necessarily utilize that that evaluation. And same thing with sentences. If we're comparing the likelihood between a couple of sentences, we can't necessarily evaluate that. So that's another problem that we can have, or another issue that can arise with evaluations. And so here are a more fine-grained existing evaluations that look at specifically bias within language models. And as I mentioned, there's like the word embedding association test, looking at different like sentences with crow-as pairs, and then there's others. So language has had a lot of work, but some of the others have had less work. Next slide. So that concludes like the first paradigm that Usman was mentioning. And now we're going to talk about people in society. So as Usman mentioned, people in society is focused more so on how like the system affects society as a whole, rather than looking at how the system is affecting like individuals, and is more looking at the impacts like more broader, versus the previous category was looking more so at the social impact of systems on a smaller scale. And so the categories we identified within this section are trustworthiness and autonomy, inequality, marginalization and violence, privacy and data protection, concentration of authority, labor and creativity, and ecosystem and environment. And like the previous section, we're not going to discuss all of them, but we'll discuss a subset. Next slide. These are the categories and more like subcategories that are described more in the paper. Next slide. So trustworthiness and autonomy. So how do we evaluate trust, and how do we evaluate truth? So this is really important with systems. If we have too much trust in a system, that can potentially lead to not great things. Like if you went to some chatbot and were like, hey, can you give me medical advice? And you really, really trusted, let's say ChatGPT, for medical advice. Probably not the best thing to do. So it's important we understand like how users feel about trust, um, how trustworthy models are, and to give us a better understanding of all of that. So the paper on the left, user perceptions and trust of explainable machine learning fake news detectors, is looking at fake news detection because models can be utilized to for misinformation and to generate fake news, which is obviously not great. And then the paper on the right is from the Ada Lovelace Institute and is how do people feel about AI? And it's demonstrating how folks feel about how beneficial AI will be for different tasks. Quite a number are positive about assessing the risk of cancer, and while there's more pessimism and other things. So with next slide. With trustworthiness and autonomy, something also that's important when we're thinking about this and measuring this is that if we over rely on models, that can potentially lead to not necessarily positive outcomes. For example, if you're a user and as I mentioned, you're utilizing some large language model to provide medical advice and you really, really trust that, that can lead to harm for you. And also when we're evaluating models, if we over rely on outputs and we assume that a model outputs are exactly like how it will perform in different use cases, that can potentially lead to harm. For example, if let's say that companies or people training models really, really care about making sure that a model isn't biased for one particular thing, let's say occupation. And so they train their model using like RLHF, so the model's not biased in the occupational context. Or let's say they put a little like post-processing, some post-processing to ensure that occupation, like there's not much bias in the occupational context. But this doesn't necessarily like fix the problems that are like within the model. And so maybe the biases that the evaluation that users thought the evaluation was catching and like was measuring are actually still being propagated in. And so with that, with our evaluations, if we're solely like looking at the outputs and are assuming that with a particular evaluation, if we perform really well on that, that means that in similar tasks or in like other arenas or other aspects that our model will perform in a similar manner, that might not be the case, especially if there's some like secondary or something, some post-processing that's happening between the model outputs, the models like the large language model or the generative AI model and like what the user sees. And so it's important to account for that. And then the paper on the right, the new report evaluating language model agents on realistic autonomous tasks, was looking at how LLMs would work if they're like given access to be able to like actually mess with things. Next slide. So inequality, marginalization, and violence. So how do we evaluate the perpetuation of inequality and marginalization of certain groups? This is a really important question, as well as how do we respect communities' choices and representation within AI systems? So some communities that are underrepresented don't want to necessarily be represented within AI systems. For example, some members of the Maori who are an indigenous community in New Zealand don't necessarily want their language to be utilized to train AI systems. And in general, indigenous communities and other marginalized communities, their choices don't seem to be really respected when we develop AI systems. And so respecting the community's choices, it's important that we have evaluations for that, and also that we, when we're utilizing aspects from other communities or languages from other communities that we ensure that that's something that the community's choices are represented within AI systems. And this question is quite challenging because even though this specific paper is discussing how the Maori don't want their language to be utilized by big tech, there's other members who do want their language to be used. And there's another paper that where the researchers were working in conjunction with members of this indigenous community to develop a system that was looking at how accurately the language was being detected with existing language models. So they were working in tandem. There's also something important to this paper, decolonizing content moderation. Does uniform global community standard resemble utopian equality or Western power hegemony? This paper, what this paper does is it looks at content moderation and how it disparately affects different community members from different communities. For example, works have found that for certain dialects, so within English, for example, African American English is more likely to be mislabeled as hate speech than standard American English. And so the authors of this paper also find that that's the case for individuals from different different communities that are not within the United States and are not super represented, and that this harms those folks. So it's important that with our evaluations that we think about how our AI systems are affecting people, not just in the West, but also in different countries who are not necessarily being represented. And then also how if we do have something that's meant to for example, with hate speech, if we're trying to prevent that from occurring, that we also think about what about the false positives? What happens when we what's the impact of when we mislabel someone as being hate speech, when their text being hate speech, when that's not necessarily the case, or in this case with this paper, moderating their content or flagging it as not to be removed when it isn't necessarily harmful. Next slide. So labor and creativity. So this is really important. How do we ensure AI systems do not reproduce copyrighted information without proper attribution? So on one of the first slides Usman was sharing, there was some lawsuits going on, and I'm going to do so. With a lot of our generative AI systems, a lot of them have been trained on copyrighted data, and so we don't necessarily want AI systems to be reproducing copyrighted data without to the original author. And so the New York Times is suing OpenAI for this. And then this has caused a lot of not positive things. You could almost say harm for artists. My sister is currently in art school, and she is learning animation, or she's studying animation. And this is something that really much is affecting her. And with artists in general, the AI systems might replicate their work, but also they'll generate art in the same style. And again, the artists aren't receiving any attribution for this or any compensation for their work being used and plagiarized. And so it's important that with AI systems that they do not reproduce copyrighted information without proper attribution. And this is quite challenging to evaluate. Also with labor, a lot of labor outside of the data that's being trained on went into training these systems. like with crowd workers. And it's important that they also have that they also are not that we have evaluations that and methods of ensuring that they're not being exploited for their labor and that they're compensated fairly for their work. Next slide. So this wraps up our presentation for the most part, and we just wanted to leave you all with some thoughts about to think about in regards to this. So who should be conducting these impact assessments? What do we do about evaluating or measuring impacts that elude measurement? We discussed this a little bit with disparate impact and also bias, how there's aspects that are challenging for us to measure, and with disparate impact, as we add more groups, the number of folks we have to evaluate for increases exponentially. And then, as I mentioned with bias, it's not quite clear exactly like what the gold standard should be, and that's important to consider. Who should red team and why? What protections should we put in place to ensure the safety of the red team? What instructions and information about the model should we provide to the red team? How should we annotate and analyze the data we collect? What constitutes a successful evaluation attempt? Next slide. And there's even more questions, which you all can read, and I won't read these ones. Okay. Next slide. I'll read these ones though. So what are the limitations of current evaluations in general? This is super, super important. What evaluations do not exist that need to? I'm sure many of y'all can think of evaluations like we didn't discuss or categories we didn't discuss that should be filled. Our evaluations resourced by modality, we saw that video and audio, there's not a lot of evaluations within that section. What categories are not present that should be? Next slide. And so to summarize, generative AI systems absolutely have a societal impact that needs to be evaluated. There's many evaluations, but there's still no standard, even with our framework. We don't necessarily like provide, we just outline categories and aggregate existing evaluations. And so with our framework, we're kind of making steps to this, but there's still a ways to go. We identified 2 categories of social impact, and we kind of outline what needs to be evaluated across modalities, but there's still a lot of limitations and gaps. And y'all should join us. This is very much a collaborative space. We had so many wonderful researchers, so many wonderful folks and brains helped on this work. So this is the first paper, and the second one is forthcoming very soon, hopefully. And then if you're interested in joining, you can contact any of us. Our emails are listed. Thank you. We're open for any questions anyone might have.
Okay, awesome, Todd. Thank you all. It's great that you're compiling this kind of taxonomy for the evaluation of the societal impact of Gen AI models. But let's bring to the first question. I think a tricky question here, especially related to the evaluation, is always what should and should not be included. And I think in your talk, especially in Jennifer's part, I think you mentioned the representational harms as a category. So I was wondering, how do you determine what types of harms are representational and what types are not? And when you are making such kind of decision, will this decision also potentially result in new undesired bias as a side effect? And if so, how can we address them?
That's a great question. I'm going to take a moment to think.
Take your time, yeah.
If anyone wants to pop in while I think.
Or maybe let's try to make it easier, maybe. Yeah, so what
it's
kind
okay.
of...
I like have...
Yeah.
Oh, I've thought of my answer now. I had like,
Of
yeah.
course, yeah. Go ahead. Yeah.
I think that's a really, really good question and really, really important. And I'm actually working on like a project kind of related to that. So I think when we're trying to address representational harms, I think what's super important is that we document like what we did when trying to not solve, but address existing biases or address existing issues within AI systems. And so with like that documentation and with the knowledge of what's been addressed, I think it's then easier for us to be able to understand, okay, if we did XYZ, then this might lead to this impact like down the line. Or maybe there's still like ABC is still an issue that hasn't been addressed by whatever our fix or like solution was to address whatever bias or issue we were currently trying to fix. I think also something that could be useful in that is when we do develop some solution, maybe I mentioned a couple questions about red teaming. Maybe we have some solution Z or something, and then we give the model or to some red team that's then able to maybe prompt and kind of like see if there's any unexpected scenarios that arise or maybe see like if let's say we tried to address bias against one group, but then the biases increased across another group, then maybe they would see that. That's not a really great answer, but
No, it's a great answer. I think, yeah, it's great that you guys are thinking some ways of addressing that. You mentioned that you have some ongoing effort. Yeah, that's great. And I do believe this is an open question. So we actually don't expect like a one clean cut answer for that. Yeah. But yeah, that's a great one. Okay, so maybe Sadika, you can take your next question.
Yeah, thanks again for the talk. It was very interesting. My question, kind of partially based on a few audience questions also, is about privacy evaluation. And so in many situations, we actually don't have a clear definition of what constitutes private information. And so it might be difficult to find a consensus or find a legal definition for when we're talking about that. And maybe one example where you could see that privacy is especially hard to define is that maybe from one person's record at one place, you can't identify who they are. But if you put together many records across many places, you find like one, you are able to de-anonymize that person. So just in light of all of that, I was wondering if you could talk a little bit more about what the privacy evaluation might look like, how you are thinking about privacy, or what obstacles you see towards like a more formal or consensus-driven definition of privacy.
So I think that's like a really difficult overlapping legal question as well with different jurisdictions and what we see with GDPR and what we see with different states. And an interesting lesson that I learned working on Big Science that Hugging Face hosted is how do you work towards privacy in a large data set? And it's part of this incredible team. Lucas Strupek led a lot of the work on privacy for the V2, which, inshallah, will come out on archive very shortly, soon to be published in the Oxford Handbook on Generative AI. This is the part of the amazing part about having experts. So learning from Lucas on the privacy side, part of what you can identify with a model are, doing some kind of classical AI like member inference attacks, but that maybe doesn't apply as well to something like a language model as it would to a different type of system. I would encourage you to look at some of his work, but specifically, what I learned from Big Science, for example, is exactly what you're saying, Sadika. Sometimes you don't know whether something's private information. Is a 9-digit number a social security number, or is it just like a random string? I think that the answer is going to have to be privacy in context, and which is why we have more strict legislation around medical information being higher privacy considerations. And this is part of the difficulty of evaluating systems outside of their context, which is the first part that Jennifer and Usman shared. That's how we're viewing privacy as an evaluation. But ultimately, I think as we're going past training data sets, more to fine-tuning data sets, more to narrow models, the most effective ones are going to look at what sector has more privacy more guidelines on what constitutes private information.
Yeah, thank you. That makes a lot of sense. Yeah. So the next question will redirect a bit to the environmental impact. We all believe like estimating the environmental burden induced by the AI system is very important, but I'm very curious about what is the ultimate goal of quantifying these impacts. For example, how might you be using the information, let's say, on the carbon emissions of different companies to construct actual policies and regulation studies? So at the end of the day, when we have the numbers, who will we pitch them to?
I think maybe I wonder if I maybe misunderstood, or if I'm getting your earlier question, Youngsibo, as well. So what is even the point of evaluations? And I appreciated Jennifer talking about how does it feed into solutions, into mitigations, and this is a question about environment as well. Why should we think about the cost of training for what that means for carbon emissions? And part of what I learned from Sasha and Michelle and people who are working on the environmental side is how few people actually even work on this, like the incentives there are to work on environment, and the lack of standards for what constitutes the environmental impact. So a lot of the tools that we list out, like Code Carbon, look at carbon emitted during the training process, very rarely, if at all, looking at inference and querying. And then there's no standards body to set any of this. Very few people even look at the water that it takes to do chip manufacturing. But to your point, Youngsibo, why are we even reporting on this? I think disclosure is a really big part of better training, better research. This is disclosure overlapping with documentation, so we can understand the impact of these systems. And then I think this is where intersectional work comes into the policy side. It's just being aware of what is the environmental impact broadly of these systems, and then what are the mitigation vantage points? So can we reduce the amount of carbon outputted? What is an unacceptable threshold? That's something that is relatively quantifiable as opposed to many of the other categories that we listed.
Yeah, that makes a lot
I think
of sense.
if I quickly add, like another way that might be important is like if a couple of days ago I saw like how Microsoft teamed up or hired a carbon capturing team in a company in Sweden to kind of offset their environmental impact credits by getting carbon credits. So it's if we're not able to capture the whole ecosystem of the environmental impact that it has, it's hard to, they're getting credits for carbon credits, which might not be inaccurate or might be underestimating the impact that they're having. So that's again another thing that's they're actually asking companies to help them reduce their carbon footprint. So estimating that accurately is kind of important for them.
Yeah, makes sense. Thank you.
So I wanted to ask, maybe it's very similar to what Irene was just talking about as well. When you have an evaluation, what we're seeing right now is a crisis where a lot of stakeholders need to buy into your evaluation, from individual researchers to companies to consumers to potentially governments and so on. And with respect to your particular framework, or in general, how you see Hugging Face moving forward in this area, what do you think we can do to standardize evaluations, or what do you think are the properties of good evaluations, or just generally, what are your thoughts on evaluations?
Well, part of why we came together is because there wasn't a standard, and something that I say I learned it was Chatham House, but a great person in our field talked about who are we to do something like standards if we're not the designated person, but also who are we not to? And this is not claiming that this project is non-exhaustive and it's not meant to be the end all be all, but it can provide a basis for moving towards standardization, especially as policymakers are starting to build up these AI safety institutes, building up capacity to set standards. I just came from a UN AI advisory meeting on socio-technical standards. So this is something that we can with our technical knowledge share. And part of what's great about working with Jennifer and Usman is that they both have deep understanding and have run evaluations themselves. And it's actually very, very rare. I'm so glad I found this incredible team. But I think just finding the people who have the knowledge right now, who have the passion to start building this, because truly we needed resources like Satika, I know like years ago. We're hopeful that we can start building it before, it's already needed, but just take matters into our own hands.
Yeah, that's great. Oh yeah, please go ahead, Jennifer.
I think also something that's really like useful about just having like something there, and I'm going to use this the example I gave earlier, like with something there or having some sort of framework, we can then critique it because it's like written down and there's something to discuss and critique and then make improvements upon, versus if like there's no evaluations or there's no framework, like there's not necessarily like something, it's a lot harder to critique and like iterate upon. And with the benchmarking data sets, which were more popular, I think like five years ago, or at least I like to think about like the Norwegian salmon paper I was discussing as we're critiquing that those existing like benchmarking data sets, which then hopefully has led future evaluations or evaluations that were developed following those the development of those data sets to be better, because they were thinking, let's make sure that what we're the examples we do have within our evaluations are more sensible, and that some of that we think about if the examples we have like within our evaluation are useful and don't have ones that make less sense.
Yeah, I fully agree that having something concretely written down is the best way forward so that discussions can actually be concrete. So we are all just about out of time. I want to ask one last question, which is, how do you see for two different groups of people, one group being people who are maybe working more technically on machine learning, and the other group being junior researchers or people who may be interested in kind of understanding what's going on in the policy space? How do you recommend that they might either join your team, or more broadly, what should they read or do to understand what's going on in the space and start contributing meaningfully?
Well, you have our emails. We will post, I have to review the last version before we upload to archive. We'll upload it to the same link. It'll just be another version. And the open question that most of us just need a breather before we can revisit next steps is, what should next steps be in addition to creating a repository? Avijit Ghosh just joined Hugging Face to help us build this repository and create this resource. We're thinking about maybe even making this a curriculum for educational resource. If that's helpful, would love to hear that. Please let us know. And then next steps moving forward, I think this is part of maybe what Youngsibo was asking. Once we've crowdsourced, please submit evals. We're going to crowdsource as much as possible. We want to think about how to compare evaluations. I think it's going to be a lot more painful than I'm excited about. But if you're excited about it, do let us know.
Okay, great. Yes, thank you so much again for giving this talk. I think it's really great for us to get also some of the more higher order thinking around what is a taxonomy for understanding these models, how can we evaluate them, and what are the considerations that we have to account for. So thank you again. This has been the past seminar. Thanks so much to Irene, Jennifer, and Usman for participating in this. And we hope that you will subscribe to our mailing list, follow our Twitter, etc., so that you can join our next talks. Thanks again.
Thank you all.